through this, make sure everybody's remembers that the session is being recorded. Please be mindful and respectful of the class environment and your fellow students. Anything you say, type, draw, will forever be recorded with your name attached to it. So please conduct yourself in a respectful and professional manner. I suppose I should have checked my audio first. Let me try that. So I'm going to go to the polling and please answer the polling question. Can you hear me? Testing, 1, 2, test, test, test. Is the audio good? Testing, 1, 2, 3. Testing, okay, good. Okay, testing, somebody's got an audio issue. Okay. Sorry. All right, so it looks like the audio is okay. And I put a message up there on the message board. If you can't hear me, you're gonna have to, if you can't hear me, you can't hear me, but there's a message there. Okay, so I'm gonna get started shortly. I did enable the audio, so if you wanna ask a question during the class, you can unmute yourself. Again, if you're not speaking, please stay muted. Appreciate that, so that we can, so that we don't hear any background noise. All right. So today I want to finish the profile design. I hope some of you have tried it or at least gotten to the point that I did where I have to go back and revisit Street B profile. And then based on the design of A, now we're going to fix Street B. And then I'll go on to some corridor modeling and a discussion about some lot grading, okay, which is the biggest part going on. Let me just check. The next assignment or the next submission is due on, just going to check the, whoops, the addendum. This should have gone. So posted on the course addendum by Professor Neruzzi. We should have course addendum here, sorry. Yeah. So the course addendum states that the next submission is due on the 9th week. So this is week 6. So 7 is next week. Then there's a week off. We have the winter break, the study week, and then week 9. So the first week back on the Friday. Okay, so I'll have that. So the date for that will be, there should be a date. I don't know why there isn't. The date for that will be week 9. So this is week 6, 7, 8, 9. It looks like February 12th. Sorry, March 12th. March 12th. Okay, so that's the next submission. There's a lot of work to do. This is probably the most involved assignment. There's a lot of work to do. You have to do the grading, which is what we're working on right now. You need the profile to do all the lot grading, which isn't terribly difficult, but we'll get to that. And then we also need to do a preliminary layout of all of the drainage area for each pipe. So now that you've got your pipes laid out, you need to, yeah, sorry, let me do that again. My apologies. So here's the addendum. It's actually online. Let me just see here. The addendum courses. MED. Sorry, I'm just courses MED. And in the course documents, you should see. Sorry, course information. There's the addendum. Okay, so let me share this with you. Sorry, I'm just bringing it up. And it's not opening. Hang on, let me do this again. Course information. So if you go to course information under course outline addendum, I'm just going to download that. So SigLink as, put it on my desktop. Okay, so let me share this with you. So go to here and go to Add desktop. Okay, so here's the course addendum. So if you look, and again, you have control over the zoom on the upper left. You can zoom in on the document. So if you look at right here, so we did this. You have your test this week. Did you have your test yet? Did you have your test yet? No? When's the test with Professor Neruzzi? Oh, next week. Oh, right, week 7, duh, next week. So Monday, very good. Okay, so that week 7 is next week. The week after that is week 8. So that's the reading week. And then week 9, the end of the first week. So I'm going to ask for your submission again on a Friday. I'll mark it over the weekend, okay? I think I got them back to you pretty quick, less than a week. So you got your feedback. Again, there was some stuff there. If you weren't sure what to do, I've been helping some students through email, and I had a few meetings last week. So if you want a meeting because you're not sure how to fix something, we'll set up a meeting. Send me an email request for a meeting, and then I'll set up the meeting and invite you to it. Okay. And if the time doesn't work, obviously we can make other arrangements. Propose a time, and then you're either available or you're not. Okay. So the second submission is due on week 9. So this is week 7. So I'm just going to check my calendar. So this is week 7, week 8, week 9. So week 9, sorry, is March 5th. So March 5th. Mark your calendars. March 5th is the due date for the next submission. And I think there's a document online that also states that. I think Professor Neruzzi posted something. Let me just check my documents, make sure I have the same information. So the second submission requirements and due date is, okay, he's got March 12th. He's got March 12th. So let me just check that again. So this is week 6, 7, 8, 9, March 12th. My bad, March 12th. So mark your calendars, March 12th. So there is a submission, MED 643 submission document for submission number 2, that states the date. Okay, let me show you that document as well. Share that with you so that we know what's going on. Sorry. Keep talking out of turn, and I shouldn't. I should have the documents ready. Sorry. So let me just bring this up. MED, submission 2, here are the requirements. So this should have been posted online. It's available. And Professor Neruzzi would have posted it. We review it together, but he's ultimately in charge of this part of it. So submission 2 requirements. And I'm going to share now. So here's the document. So these are the requirements. So we'll go, before we get too far into it this week. On the base plan, if there's anything if there's anything in submission 1 that hasn't been updated. So you remember when you got your email from me, anything in gray, the alignments, the edge of pavement, or the surface, if there's anything wrong with that stuff, you have to correct that because it's going to affect what happens next. The other stuff, like I said, if you want to correct them on your own time for the sake of having a portfolio that's all up to speed, you can do that, okay? But it's not necessary for the course. So you don't need to go back and fix those things. I've marked them once. I'm not taking marks off again, okay? But certainly if you have the time, you want to tidy that up, because if you want to use these drawings for a portfolio, you want to make it as clean and crisp and correct as possible, okay? So I'll leave that up to you to decide when you do that. I still recommend you do it. It's good practice, but I won't be marking it again, right? So if you don't update those things that aren't highlighted, that's fine. So right now we're working on the profiles. So this part here, okay, we're working on this part here together. So we're going to design the road profiles. This here, the shortcut for the surface, that's already done, and the style and the label style is given here. So on the plan now, when you when you send me your DWG again, I want to see the style for the existing ground surface, right? With a major contour interval of 1 meter, minor contour interval of 0.25, and then a major and minor precision of 2 decimal places. If you don't remember how to do any of this, you can go to the CDA reference files, okay? And that'll walk you through creating surface styles and surface label styles, okay? It's contour label styles. Okay, so that's really just do it. You should be familiar with it, and if not, there's reference documents for it. So right now we're in the middle of this, right? We're designing the roads. I did street A, I did part of street B, then I revisited A, and now I gotta go back and fix street B. So that's where I'm going to start today. So that's the requirement for the road design. The road design is going to lead to the grading design. We're going to get our front lot corners from a corridor model that we'll create from these finished profiles. So you have to do all the lot grading. The lot grading is important because the drainage area plans, both of these plans, right? You have to draw the tributary area for each pipe, and I'll demonstrate that next week. You have to draw the tributary area for each pipe. This you can almost do without the grading, although there is some information from the grading plan, really the profiles. You need the profiles done. So you don't need to do the lot grading for this one, for the sanitary, but you need the lot grading for the storm. You can't do storm drainage area plans without the lot grading. Okay, so this you can do right now, actually, once we're done the profiles. So once we finish this discussion today, then we can do this. If you want me to show it to you today, if there's time, I will. Otherwise, you have to do the grading plan first so that then you can do the drainage area plan for the storm. Okay, so there's a little bit of order here that's required. Okay, and then the requirements are to show the areas, the population and density for the sanitary drainage, and to also show the, the drainage bubbles. There's an example online of what the storm drainage plan and the sanitary drainage plan looks like. So there's the areas for each pipe, and then there's the ID information, which shows you the area, the population and the density for SAN, and the drainage area for the storm shows the area and the runoff coefficient. Okay, so we'll talk about all that when we get to it. Can't do any of this until the roads are designed and the lot grading is done. Okay, so right now we're into here. The lot grading won't be terribly difficult. Okay, I have a lot of confidence in your lot grading ability because when I taught you last semester, I know you had a lot of practice, and there was different grading types. You remember front drainers, split drainers, walkouts, back splits. Remember all the different types? On this particular site, the characteristic of almost all the lots is simple split draining lots. Okay, so remember high, low of 2%, 2%, or high, low of 2%, 3%. And almost the entire subdivision is like that. So there's a lot of work, but it's almost all the same design concept on each lot. Okay, so it won't take too long to do. The heavy lifting in this particular course right now, or in this particular project, is the profiles that we're doing, and we're almost done. Okay, then the rest of it is kind of just follow a process, right? Do the lot grading, get the drainage areas. I'm going to review your drainage areas as part of this submission before you go to your design sheet to actually size the pipe. You need a slope and a size. You need to determine that from a spreadsheet, and you can't do that without the areas. So I want to review the areas first, so that you have a good sense of whether your areas are representative, makes sense. Okay, so if you don't draw the areas correctly, you're going to get the wrong area. It's going to affect your pipe size and so on. Okay, so we'll get to all that. So after the break, when we get into the servicing design, we'll have done all the preliminary layout of the drainage areas. You'll get some feedback from me because I'm going to mark it, and then we can go on to do the servicing design. And that's really the last part of the design, the servicing design, where we put in all our pipes. We'll finish the plan with some more information like rear lot catch basins for drainage. Can't do that until the grading's done. Street catch basins, we can't do that until the profiles are done, so it'll all follow. So there's still a lot of drafting to do, but you can't do any of it until you get the profiles and such done. So again, just a bit of a preview. I hope this is making more sense now than it did last semester. The design process, okay, is exactly the same as before. There's just a lot more detail involved now. You know, what to do first, what to do next. It's kind of the same order of operations. Okay, so I hope this is familiar, and I hope that you can see the value of taking that CDA course, right? That background, those skills, those techniques and tips and tricks and so on hopefully are paying off this semester. Any questions about that so far? Just an overview going forward. Okay, and the due date is right there. Sorry, my mistake. Friday the 12th, which is week 9. Week 9. Any questions? Okay, so let's get on to today's lesson. Again, I'm going to share my screen. Let me bring this up. All right, so for the lot grading tubs, would you need to look at the corners to see if they're different? Do you mean like the flank lots, the ones that are against the roads, Stephen? Well, you mentioned that most of the lot grading is the same. Yeah, most of it's the same. There's a couple of exceptions. I think there may be a couple of back splits, but generally they're all split drainers. Okay. I'll do a little bit of demonstrating of the lot grading design, and I'll give you the parameters for it. Remember the setback from the front, the depth of the house, and so on. So we can talk about that once we get to it. But we're not there yet. We have to finish the road profile design. Yeah, Claire, sorry, I haven't emailed you back. So if your alignment is short, right? This is what's happening with Claire. Sorry, I don't mean to single you out, but you asked me in class. So if your alignment stopped not at the street line, right? This is the right-of-way line. Just click on the alignment, go into the grip. Don't touch the labels. Grab the alignment center line, go into the grip, and then INT for intersection. Take it to the intersection of the center line all the way to the street line, and that will extend the alignment, and that should give you the correct station at the end. Okay, that's how you do that, Claire. Sorry, I didn't want to email you. It would have taken me longer to explain it than to just show you, so I'm glad you asked in class. Okay, so try that. All right, so let's go look at the design again. If you remember, I designed the road profile on Street B here, and then when I projected the design of Street B onto the plan and brought it to the profile of Street A, we found we were too short. We were too low, right? So this is what I designed. That's the elevation based on my work on Street B. Right, so if you remember the low point, right, I designed the low point station. These are just the station values. So I designed the low point elevation, right, which is the point on the profile where this gutter extension is, right, the extension of the gutter. So I designed this location, and then when I interpolated this value from the design, so I know the profile design along Street B, the elevation along Street B at this point is what you see there. 195,658. When I projected this to the plan from this profile, now I'm going to project this point to this profile, which is where we left off last day, and I find that the point is here. It's down here. Okay, that's for reference. There it is. I can't be that low, right? I want Street A to all flow from this intersection all the way to the exit of the site, which is down here, right, where Street A meets Ledger Way. But I want to do it with minimum grade. So let's forget this point for now. Let's forget we see that for now, and let's design this, right? Well, we designed from the edge of pavement down to the low point, up percent, and that's what I started the design of Street B at the end. Okay, so that elevation is fixed at this end of Street B, right? Which is this intersection here, right? So I designed from here all the way to here, and then I took that all the way around to here, and then I designed this piece. Then I brought this intersection elevation to Street A, and it's just there for reference, right? So we find that it's here. How did I develop this? Minimum slope. So I came from that intersection at the end of Street B, and I'm going to come up at the minimum grade, and then when I get to the projected gutter line, I'm going to go up at 2%. So this is half the road section of Street B, right? The distance between these 2 points is basically the distance between these 2 points, right? The cross section here. If I design it with minimum slope all the way up to here, the profile of Street A looks like this, right? We come down to the low point, to the end of Street B, and then all the way to Street B at this end. And we find as a minimum, this crown has to be up here. What I currently designed, it's close, but it's too low. If I lower this, right, I'm just going to trace this so you can see what I'm talking about. So if I draw a polyline from here to here and then just anywhere here, if I take this design and lower it down to here, node, then the only way to make this work is to have a low point. Is to have a low point and a high point, right? So if I do this, just schematic, right? If I do this, then I can come down to here and then come back up and match this 0.5% grade, right? This 0.5% grade coming up. If I do that, then I have a low point. I'll end up with a low point here. I'll end up with a low point here. And I'd probably place it strategically at this perpendicular at this station. So I could put a low point here. So down 2%, down 0.5%, and then I would come up a 0.5% before I come down. So that would give me a high point here. I'd have a high point here. Whoops. Just want to label it. I'm going to have come on. I'm going to have a high point here somewhere, a high point here somewhere. Here somewhere. Oh, come on, sorry. I'm going to have a high point here. So I'm going to turn my O-snaps off, causing me too much problems. Okay, I'm going to have a high point here, a high point here, and a high point over here, if you remember, right? So now I have a high point, a high point, a high point, and a low point right here, right? There's a low point on the profile here. So now if you notice the drainage, I've got 3 high points and a low, no outlet. It's got no positive drainage. So what'll happen when it rains during a storm event that the sewers are over capacity, I'll end up with a big giant puddle until the water gets to a level either higher than this point or this point. This will probably be higher than both of those 2 elevations. So I'm going to end up with ponding on the pavement when it's not necessary. So if I start my design here and I come all the way up to the intersection without a high point here, if I get rid of this high point, then when it rains and the sewers are full, water will come down and around this way, and from the high point down and around this way, and I'll get positive drainage all the way out here. So I don't want to have an arbitrary high point here where I unnecessarily create ponding on the pavement. So I don't want to put a high point here. So if we go back to the discussion here, right, I don't want to have this high point. I want to have it all draining, right, from this intersection all the way down to here. So to do that, I'm going to start here. I'm going to go up at minimum slope all the way to the end. So as an absolute minimum, so that I can avoid the high point, this is the elevation of the road. So now this is too low. So now I'm going to go backwards. And this is kind of a theme in municipal design. You did one part of the design, and then you're going back to make it all work together, and you find out what I did before on street B isn't compatible with what I need to do on street A. Okay, let's finish the design of street A. What should it be? Okay, it needs to be up here. Okay, so let's get rid of this. Let me project this elevation to the intersection, and then take that point in the intersection on the plan and project it to street B, and redesign street B to match this elevation, not the other way around. So it's a little bit of chicken and egg. Which comes first, right? Well, you don't know until you try one, right? You try the egg, it turns out the chicken should have come first. Or you try the chicken, you find out the egg should have come first. And you won't know until you pick one, right? It's a cyclic type of process, and you have to jump in somewhere. So you have to do one thing or something, and then see how it compares to the other things you need to achieve. And if they're not compatible, whatever you assume to work on one side that doesn't with the other, now adjust the last thing, and then adjust the first thing to match. Okay, and this is just the nature of it. Okay, this subdivision, I change it every year, so I never know how it's going to work out. Sometimes street A governs and sometimes street B governs, so I never really know the solution until I'm kind of going through it with you. So I'm kind of designing this live on the fly as a demonstration, which isn't always a great idea because sometimes I'm not prepared to see what happens, but I have a sense that I know the process. So whatever I do, if it doesn't work out, I know I can go back and check it. So in this case, I think it's a good learning exercise for everybody, right? You tried one thing, tried to make the other one match. It didn't work. Now you're going to go backwards. You're going to design street A first and now fix street B. If I had decided to do all of street A first, then I would design B and it would work and I'd be done. I wouldn't have to go back and forth. So sometimes it works out and sometimes it doesn't. Okay, so the process for taking that profile elevation to plan and then from plan to the other profile is this. We've looked at this before, right? So this is no good. This elevation came from this profile. I want a point elevation here from this road's profile. Okay, I'll leave this here for reference. You'll see the design from street A is going to be higher than this. Okay, so how do you do that? I'll show you. We go back to points, create points, and from this dialog box, why is it being funny here? Points, create points. I don't know why my dialog box isn't showing. Let me try it from here. Same thing. My graphics kind of not working across here. Oh well, as long as the function works. So we'll go back to this one, station offset. It's going to ask you, pay attention to the prompts at the command line at the bottom. So which alignment? I want street A alignment. Which profile? The finished ground, the design, not the surface of existing ground, the design. I'm going to say OK. I'm going to snap to this location, the node or the intersection of the two lines, right? The intersection of the two center lines. And then it's going to ask me for an offset. Just say 0. I want it right on the mark. So this elevation that I produced now should be higher than what you see here. Okay, and there it is, right? 74. So instead of 0.66, it's 0.74. So it's about almost 4 inches higher, or 0.1 higher, right? 0.09. Okay, so I'm going to get rid of this. I don't want to use that. So now that I have this elevation from this road's design, I'm going to project this to this profile. This I taught you last semester. And we go to profile, project objects to profile view. I want to take this, enter, to street B profile. Oops, do that again, sorry. I want to take this, enter, to this profile. It's going to come in here, right? It's actually going to come in right here. This is the intersection point right here, right? Not this one and not this one, but right in the middle. And why won't it project? Try this one more time. Project this point to this profile. And the elevation, keep it, right? It's the elevation from the other profile design. So don't change anything here. And there it is. So this road profile should be up here. Okay. Now to fix this, we have to deal with the high point on both sides. Okay. Let's deal with this side first. Okay. I'm going to raise my the elevation of the top so I can get rid of these. See, these labels are in the middle of the two lines. I'm going to change the profile, and you'll see here it's 197. I'm going to change the profile grid. So I'm going to go to Profile View Properties. I'm going to go to the elevations, and instead of 197, I'm going to specify that myself. I'm going to add 3 meters to this, just so the top of the grid is higher. All right, so now the labels are out of the way of what I'm trying to draft. Okay. So the station location of the low point, this point here, is not going to change. So I still want my low point at this location. So this station is correct, but I want the elevation to match this. So from the low point, I want to come up this way at 0.5%, and from the low point, I want to come up at 0.5% this way. One technique I like to use, and this is again a tip and a trick, if you will, is to trace this design with just AutoCAD lines and draw my solution using AutoCAD, and then make the design database match. Okay, so here's some one way of doing this. So remember, from here to here is 10 meters. This is just interpolated on the intersection. So both this piece and this piece are at 0.5%. Right, I'll show you here. They're both 0.5%. So from the low point, we're coming up 10 meters. And along the way, we're going to interpolate the elevation of the intersection. Okay? So I'm just going to draw a line from here to here. That's 10 meters long. Okay? What I want to do is move this from here up to here. That's where the design wants to be. Okay? Now on this side, I got a couple of choices. You remember this high point? Up 10 meters, down 10 meters, this location? The location of this high point is based on, if you remember the plan view, this point right here. Right? So from the curve, 10 meters this way, so this is down at 0.5% in the profile, and from here it's down 0.5% in the profile. Or up 0.5% to here, down 0.5%. So the station location of this high point, I've already fixed it, so I don't want to change that either. So we'll go back to here, right? I don't want to change the high point station. So now I've got a couple of options. Let me draw a line here. I'm going to trace it just so I can, again, I want to draw my solution using AutoCAD lines, and then I'll make the database match. So I'm going to draw a line from this point to this point. So there's our 0.5% up, and then on this side, 0.5% down, right? So this is that high point. This is the curve between here and here, right? It's a little bit steeper for the gutter. Okay, and then I drew this piece in between at 1.5. Why? Half, 1.5, a grade change of 1%. 1.5, a half, a grade change of 1%. I'm able to avoid a vertical curve. So now I've got a couple of options. Actually, there's more than one option. I'm going to draw that line so that I can have a 1.5% grade. I could raise this up to here and extend this 10 meters, right? I could extend and push this PVI, whoops, push the PVI. This PVI, I could push it to here and make this longer than 10 meters in design, right? That's one way of doing it. Or I can leave this where it is and take this 1.5%, right? Draw it again, take this 1.5% and extend this. Remember this little 10 meter long piece? I can extend that to here and move this PVI and have something greater than 10 meters here. Okay, so there's a couple of options, right? Now, which is the preferred solution? There really isn't one. You can actually do anything in between, right? I can make both of these longer. This is 10 meters. This wants to be minimum 10 meters. I can raise this, right? I can raise this all the way to here, right? Or I can have it down here. These are my solutions, or anything in between. It's not a lot of range, right? I'm gonna make a copy, right? So I could be as low as this and make this piece longer than 10 meters, or I can be as high, sorry, I could be I could be as low as this and make this 10% piece longer, or I can be as high as this and make this 10 meter long, 0.5% piece wider. Let me draw this out to the side. Hang on. This is fixed, right? I'm going to draw this. This elevation is fixed. That's my high point. This elevation is fixed. That's where you come down the low point. And they're both 10 meters long. This piece and this piece are both 10 meters long. And this is the piece in between. Let me draw it down here. It might make more sense. Okay? It's important to the design. Okay. So this elevation here is fixed. Can't change that. This elevation is the low point. It's fixed. Can't change that. Now I got a choice of where to put this, right? This is 10 meters long. I could keep this right here, so raise this as well and extend this piece, right? So there's one solution. Make this one longer than 10 meters. Or I can do the opposite. I can keep this one here and extend this piece and make this one longer than 10 meters. Or I can do anything in between, right? I can go as low as here, I can go as high as here. So anything in between will do, right? This could be here, it could be here, or it could be anywhere in between, right? Those are the only options, okay, with these three slopes. Now what you have to think about is earthworks, okay? And I know for a fact, if you look at all the road profiles, my design is always higher than my existing, for the most part. My design is higher than my existing. So I'm pretty sure I'm going to end up in a deficit. I'm not going to have enough material on site to build these roads, right? So my design is always higher than my existing. So I want to do my best to keep the design as low as possible. I don't want to unnecessarily fill if I can avoid it. So of these two solutions, I want to keep this as low as possible, because if I use the higher design, then I'm going to have the difference between these two, that much more fill material, right? So I'm going to keep the lower one and I'm going to extend this and make this longer than 10 meters. So I'm going to keep this 10 meters at 0.5%. I'm going to come down at 1.5%, but instead of here, I'm going to be over here. Okay, and that's the preferred solution on this side. Okay, so I'm going to trim this, and this is what I need to do. So I'm going to bring this back to here. Let me erase all the lines we have here. Okay, there should be no polylines here. Okay, so I'm going to bring this solution, 10%, 1.5, and this will be longer. So come up here, put it back here, right? So that's not going to change, so I don't need this. This PVI here is going to move over to here. And then this can come up to here, node, and this can come up to the high point to match, or sorry, to the low point to match. Oops, did I do it wrong here? Oh, yeah, this needs to go here, node. Okay, so there we are. So now we have from the low point all the way to here is 0.5%, and then we come up 1.5. So the sum of this and this is more than 10 meters. Okay, so that's the design on this side. Now on this side, I got to fix this again. And I'm going to do here exactly what I did before. I'm going to come up at 0.5%. So I'm going to trace this. This is 0.5%, right? I'm going to start here and go all the way to here. I'm going to mirror it because this is positive. I want it to be negative. So vertical mirror. Oh, where did it go? Sorry, I scaled it. This line here, I'm going to trace it. So from here to here is 0.5%. I'm going to take it and I'm going to mirror it to the other side. Now it's negative. And then I want to fill it this 1.5, this 1.5% grade, and this 0.5% grade, right? And now at this PVI, I have 1.5 positive, negative 0.5, a grade change of 2%. So now I have to play that game that I played last day, right? I'm going to make a copy of this and this. This is a PVI with a grade change of 2%. So I'm going to put in a 10% at 0.5%, 10 meters at 0.5%, this piece here. Right? So this is something I demonstrated last week, but I have to do it again. Okay, so I'm going to take this one here. I'm going to take this one here. I'm going to fill it with a radius of 0, 1.5 to negative 0.5. So this PVI has a 2% grade change. This PVI and this PVI has a 1% grade change. Okay, so now I want to put this in relative to these two positions up above. So I go back up here, and I know where this one crosses this one, right? Because I've traced both of them. So now I'm going to take this from this PVI to the same PVI up here, and that's where my design should be. So now I'm going to take this one and bring it up to here. This one will be over here, and that's it. Don't need this anymore, don't need this anymore. And there we are. 10 meters between positive 1/2, positive 1/2, negative 1/2. So now I've transitioned. So I moved the high point on this side a little bit. And now I have an elevation that's the same at both intersections. And now my road profiles are done. Okay, so a little bit of back and forth. Again, it takes a little bit of getting used to. A lot of people don't like the idea. When you're used to doing a problem in math or even in steel design or whatever it is, you kind of start your design, especially if it's hand calculations. You start at the top of the page and you work your way down and you get to the end and you're done and you're happy and everybody's cool. This kind of work, because there's so many moving parts, because there's so many pieces that have to work together, you can advance the design on one front and find that on another piece of the puzzle, it's not compatible. And it is an iterative process. And I've said this before, municipal design is an iterative process. And you'd like to iterate once, which is impossible. So you have to accept the fact that you may have to go back and revisit or redo some of the work you've done before to make it compatible to the problem you're having at the current stage of the design. And that's just the nature of the work. Okay, don't get upset by it. That's just the way it happens. Because again, there's so many things at play that you can't possibly cover every case for everything you're going to encounter until you're completed one full cycle of the design. So it's kind of, I don't want to say it's 2 steps forward and 1 step back. The progress is much better than that. It might be 10 or 12 steps forward and 1 step back, or 15 or 20 steps forward and 1 or 2 steps back, and so on. So you're always advancing the design, but you're making everything compatible along the way. Okay, so that takes a little getting used to. If you're used to just zeroing in on a solution, you know, from beginning to end without revisiting anything, you're gonna have issue with this. It takes a while to get used to, and it's something you're just gonna have to accept. Okay, any questions about that? Okay, I'm actually glad that it didn't work out the first time. Okay, I'm glad that I had to go back. I did part of Street A, I completed Street B, I checked it against Street A, it didn't work. I'm glad that happened, so you can see what I'm talking about. Okay? Now the nice thing is, it's an iterative process. You'd like to iterate once, which is impossible. It's not going to happen. But I will give you this. Over time, the more experience you have, the less iterations you'll perform, because you'll find it's very, very similar all the time. The processes you go through, the ideas of, of things that you've encountered before will come into play, right? So any previous experience is going to help you make decisions going forward to help eliminate the number of iterations. Okay, so the difference between me and you now is I can't iterate once. It's impossible, but I iterate less because I have more experience, and that will happen for you in your career for sure. The more you do of these, the better you'll be at them. Okay, and the less kind of the less iterations, the less revisiting you'll have to do. But you'll always have to go back to change. Okay. The other thing that happens, unfortunately, is changes happen. Right. You'll get the subdivision might change. They might move a road on you. Design this now. Well, I already did all this work. Yeah, well, you got to kind of put that aside and design it against the new plan. Or this changed. Or that pipe you're connected to, it's actually not there. What are we going to do now? Oh, geez. Or it's too low or too high. How are we going to fix that? So sometimes you get information related to stuff that you thought you knew, and then it turns out you didn't. So you made like one of the assumptions I'm making is that this road design is built exactly as the design. I'm assuming I'm designing my road against the design of the previous road. Well, this is built now. I hope they built it in the right spot. So sometimes you go back and say, okay, you know what? It turned out that road was actually built 4 inches lower than you thought. So now I have to go back and revise my design and so on. So there's always information that comes to light, not just the design process, right? There's that part of it, but there's also new information or updated information. You might get a brand new topographic plan with more data and so on. So there's always stuff that it's going to make you revisit, yeah? until the current data set, everything's up to date. You have all the information you need. Sometimes you start the design not with everything you need, and then you'll appreciate that iterative process. So sometimes there's things beyond your control, and sometimes there's things that you're in control of, but you haven't gotten to that stage of the design yet. Okay. Any questions? There should be lots, I hope. And again, if you want to unmute yourself to ask a question, you can. You should be able to ask the question instead of type. Claire, were you able to fix that? You still there, Claire? Okay, great. All right. Oh, sorry, hang on. Was somebody talking? My earphones were muted. Sorry, I just noticed. Was anybody talking? I hope not. Sorry, my volume was muted. I couldn't hear anything. Okay, so now I have the design. Okay, so if there's something more specific, Claire, send me an email and we'll have a meeting and we'll discuss your specific issues. Okay. The next thing we have, the final part before we get to the corridor, is to design the elbows. Remember the elbows? Actually, you know what? Let me start the corridor model, and you'll see that the elbows aren't correct. You'll see that they're off a bit. Okay, so let me do this. I already started building my corridor. Already have ledger way, if you remember. Okay, now I'm going to change the rotation so I don't get a kink in my neck. Okay, here we are. So we already have the corridor model started for ledger way. If you remember, we did that together. I showed you that before. So now I'm going to add to that corridor. I'm only going to have one corridor model, remember? So I want to add to this corridor model. So just the same way you splice in the elbows, you can add baselines of other roads or other alignments, more specifically. So I'm going to take this, right click, I'm going to go to corridor properties, and you'll see in the parameters one baseline. This is called the baseline, where you identify the horizontal alignment and the vertical alignment. And then if you click the plus sign, you'll see the region. That's where you define the cross section. Okay, so you need plan, profile, cross section. So before we add any roads, I need a new cross section. What's the right-of-way width for our road? Anybody remember? What's the right-of-way width for road street A and street B? If you don't remember, measure it. Yeah, 16, right? So I don't have a cross-section, 16-meter right-of-way, so I'm going to create that. Remember, you need a plan, profile, and cross-section. I don't have cross-sections representing street A and B. So I'm going to go over here. I'm going to go back to my plan view, and I'm going to go over here. So if you remember, this is the 20-meter wide section that I prepared for Ledger Way. Okay, I'm just going to cheat. I'm going to borrow from here, right? I'm going to make sure that I have the alignment, the cross-section I need. So under MED, under project files, I should see my, whoops, under Town of Milton, standard, E2, right? So I want to do all this. I want to create my cross section like this, right? 4-meter wide pavement. The gutter, remember, is going to be 0.3, 0.05, 0.15, 300%, sorry, 8.33%, 300%, 0%, and then the rest is all boulevard. And you'll notice this boulevard width is going to be, this is 16, divide by 2 is 8, subtract 4.5 from 8 is 3.5 boulevard. All right, so back to here. So I'm going to make a copy of this. Now when you copy this, only copy the assembly point, not the sub-assemblies. This is the assembly. All the pieces connected to it are sub-assemblies. So you just need to copy the assembly. All the other pieces, the sub-assembly will come with, so you don't need to worry about those pieces, okay? So don't copy everything. If you do, it causes a bit of a mess, okay? So just copy the center point. I'm going to bring it over to here near street A, and you'll see all the assemblies come with it, okay? The pavement has to be, if I change these, the pavement has to be 4 meters on both sides. The gutters are the same. The gutters are 0.3 at 833, 0.05 at 300%, and then the top curb is 0.15 at 0%. So that's the same on both sides. And now I just need the boulevards. These should both be 3.5, 3.5, up at 2%. And then if I measure the distance from this endpoint to this endpoint, I should get 16. This is my check. That's good. So I know that I've modified this correctly. And then when I click on the assembly point, I'm going to change this to 16 meters. 16 meter right away. So now I have two cross sections. Okay? They both have pavements, they both have gutters, they both have boulevards, but I've changed the width of the pavement, the asphalt portion, and I've changed the width of the boulevard. So now I have a plan for street A and B, a profile for street A and B, and a cross section that's going to be used for both street A and B. Okay, let me go back to my plan. So again, this is a bit of review from last semester. Creating your alignment, creating your corridor, sorry. So let's add to this corridor. So I'm going to take this corridor, right click, corridor properties. So I'm going to add street A, so add a baseline, just like you would add a gutter, right? So this, I'm adding a road, not a gutter line, but it's just an alignment. Whether it represents a center line or a gutter doesn't matter. So add the baseline. Which one? I'm going to choose street A, say okay. Then where it says click here, that's where you take the design profile. Remember, there's always two. This is the existing ground. This is the proposed ground. This is the red dashed. This is the green one, the design one. Say okay. And then to add a region, you have to, notice there's no plus sign here. To add a region, you right click and you say add region. And then you take the 16 meter right away and say okay. And that's street A. I'm going to say okay, but we got to come back for B. Okay. Rebuild the corridor. And now you'll see the corridor for street A. Right, street A and Ledger Way together, one corridor model. All right. Street B is done the same way. Right, so we click on here, right click, go to corridor properties. If you don't like, you know how when you have here a choice between FG and surface, if you don't like the surface, you want it to say EG or existing, this is where you change that. Some students have asked. If you go into tool space, under alignments, under centerline alignments, under Ledger Way, I think I've done this on Ledger Way, under the not the view, that's the grid, the profiles, these are the actual data. Here's where you can change the name. So if you don't like the design, FG and surface for existing, you can go to properties. What I do is this, I go to here, properties, I copy this, Control C, cancel, I go to here, properties, paste, and make this EG. And now I have the both. Okay, so be careful. If you change the name, make sure you choose FG for the corridor, not EG. It's a common mistake. All right, same thing here, profiles, properties, Control C, copy, change the surface property and make it EG. And do the same thing for street B. It's just a housekeeping information here. I've got 2 for some reason. I don't know why. I'm going to delete one. Doesn't matter. Existing ground. I must have done it twice. And then street B, the profile. I forgot to name it FG. So I'm going to go here and change the name, dash FG. I always repeat the alignment name and then add FG. FG. Copy this, say OK, and now rename the surface to existing. And now the names make more sense. Okay, you can call them whatever you want. The names don't matter, but if you give them meaningful names, it's easier to find stuff, right? So that's my advice to you. Again, some more housekeeping tips and tricks. Let's go back to the corridor and add street B. So click on the corridor. Notice it's one corridor. It's got both roads on it. Go to corridor properties. I'm going to add another baseline, street B. Say OK. Click here, make sure you choose the finished ground, not the existing ground. Be careful now, right? The name might be confusing. So FG. And then right click, add a region. And you've got your 16-meter right of way, right? So now you have 3 roads, 3 alignments, 3 profile designs, and 3 assemblies with sub-assemblies. A 20-meter right of way for ledger and a 16-meter right of way and a 16-meter right of way. Say OK. Rebuild the corridor, and now you have street B connected. Okay? So more housekeeping tools. Again, I'm going in and out of this dialog box. You can do everything all at once. Okay? The only time you have to go out and come back in is when you're splitting the regions, which we'll get to in a little bit. Okay? So you can see here in the corners, they don't look very curvy, right? They don't look very representative of a curve, so we have to go back and change the frequency. So we'll go back to corridor properties and we set all the frequencies. And again, all the tangents should be 3 meters long minimum. Every 3 meters you want cross-section data, and then the curves every 1 meter. The last 2 for this design are redundant. We don't have any spirals, we don't have any vertical curves, but horizontal curves is going to be important. I'm in the habit of changing this from 3, 1, 1, 1, whether I have spirals or vertical curves. Say OK and watch what happens in the corners. It's going to look more like a curve. Now, even though they're straight lines, it looks more like a curve. And you can see here, this is the gutter line, and this is the gutter line, right? This point here, this is the edge of asphalt. This is the gutter line. This width between these 2 lines is the face of curve, that 300%. And this is the flat top between here and here. So you can clearly see the edge of asphalt here versus this, the edge of pavement here, which is the gutter line, versus this position for the gutter line are clearly wrong. And that's also true here, right? The pavement is here. It's actually on the, it's on the alignment over here. On the corridor, it's out here. So this should actually be right here. Same thing in this corner, okay? So it's not as big a bulge as you saw in Richmond Hill, right? Where it really curved out, where it was, obvious. It was really pronounced. Very subtle in Milton, but you still have to deal with it. I'm going to demonstrate 1. Okay, there are 3. 1, 2, 3. There are 3. You only need to do 2. These 2, the ones inside the site. So you could ignore this because we're not doing any lot grading there. So you don't have to fix this. If you want to, you can, but it's not necessary for the design. Because remember, all our work is happening in here, right? This is the property line. So this doesn't really need to be up to date. Although, if you want to change it, you can. It's up to you, but you can. Okay. You only need to fix these 2. I'll demonstrate 1, and the other one should be similar procedure. Okay, any questions so far? Okay, so what I'm going to do next is review. The geometry is different. What I'm about to do as a process is exactly what I taught you last semester. Okay, so before I do that, I'm gonna create. I need a horizontal alignment for the gutter. I need a vertical alignment for the gutter, and I need a cross section for the gutter. Okay, so let me build those Civil 3D components next. Okay, so the horizontal alignment, I'm going to freeze the corridor temporarily. I don't want to see this. So I need an alignment that goes from this dot along the green line to this dot, because that's the zone where the widening is. Okay? Everything over here is typical, and everything on this side of the curve is typical, but everything between these 2 points is where the widening happens. Okay? So the bulge is on the outside of the turn. This is typical. Between here and here is a constant offset. From here to here, it's widened. Okay? It's very subtle. So I need an alignment along the green line. Okay? This is the advice I gave you last day. Don't create a horizontal alignment that starts exactly at the beginning and at the end of the widening zone. Make sure you start a little bit before and you end a little bit after. Okay? Now, because my chainage is increasing from this direction, it's increasing in this direction, follow my cursor, right? This is 520, 540, 560. I'm going to have 0 at this end, and it's going to increase in the same direction as the center line, okay? Just so it's consistent. It doesn't matter, but it's easier to see if you're going the same way. So let me draw a polyline. I'm going to turn my O-snaps to endpoint. I'm going to draw a polyline, not at this point, but just before. So I'm going to use my near O-snap, near. So don't start right there, a little bit before. Doesn't matter, don't go too far, but a little bit before. Then I'm going to go to the end here. I want to mark the spot. This is redundant. You don't have to, you don't need this spot. Okay, so if you don't want to put one there, you don't have to. So I'll skip it. So I'm going to go to the beginning of the curve. Now this is a polyline. I want to go around the curves, A for arc. And I go to the end of the curve, and then L for line. And I go not to here, but beyond. So near point, beyond. So now I trace the gutter, but it starts before the zone and it ends after the zone. Okay, and this is part of what I used to say last semester. Remember, if you have an open net, never aim for the post. You want to do all your profile work well within the limit of the horizontal alignment. You want the horizontal alignment limits to be greater than the profile design within it. You don't want to design them at the edge. You want to be inside. Okay, so that's the alignment of the gutter. Okay, so I need to create an alignment for this. You have to do the same thing here. Now, if I was naming, here's my naming convention, right? This is going to be, if you start at the beginning of the alignment, there is 1, 2, 3 crescents. So this is the third crescent. So this is going to be street B, crescent 3, and is it left or right? Is this alignment left or right of center? It's on the right side, right? From the center line, if I look in this direction, this is the right side of the road. Okay, so that's the naming convention. So whatever this alignment name is, it's called street B, copy. So here's the alignment. Alignment, create by polyline. Pick this end. I want 0 at this end because I want positive chainage to increase in the same direction as the center line. Enter. That's correct. See that little indicator, that little arrow? Enter. The name is going to be the horizontal alignment name, crescent, or elbow, or knuckle, or eyebrow, whatever you want to call it. It's the third one from the beginning of the center line alignment, and it's on the right side. Okay? The other ones will be named crescent 1 on the right, crescent 2 on the right. Okay? And then I don't need any extra curves, so turn this off and say OK. And there's your horizontal alignment. 0 starts here, and you can see 0, 20, almost 30 meters long. All these labels in plan, you don't need them, right? No one needs to see this. It's only to create a corridor model that's representative. Okay, so I'm going to delete them now that I've seen them, right? I'm happy. I've got everything. I'm going to delete this one too. Okay? I don't want to see this, so I would put this on a frozen layer after. The only reason I'm creating this is for the sake of the corridor model and the surface of the corridor, ultimately. Okay? But to check, make sure that 0 is here and it's moving in the same direction, right? So it's increasing on screen from left to right. Okay? But you don't need them at the end of the day. Plan view. Go back to my profile work. So now I know that that elbow on my street B profile is right here, right? This is the last one. There's an elbow here just before the high point coming into the site. There's an elbow here near this high point, right? There's 2. So this is my elbow and this is the elbow I'm working on. There's 2 elbows inside the site. Here's my layout procedure. Don't need any of this crap here, right? Here's my layout. I'm going to draw my profile. I'm going to assume this is my center line. So anything that's on the right side of the road, I'm going to draw at the bottom. Anything that's on the left side is going to be drawn on top. So now I'm laying out my, and I'll move this for now, right? I'm going to lay out the position of my profiles in a relative way so it's easy to find. Okay, so this is the center line zone where the widening is, where the elbow is, right? So the bottom of this main road is going to be anything on the right, and above is going to be anything on the left. And then I stay organized. You can put them wherever you want, but if you lay them out relative to each other in a way that's easy to kind of follow, it makes more sense. So I want to draw the profile of the existing ground of that alignment I just created. So we go to Profiles, Create from Surface. This time I want the crescent. I want the existing ground, add that. I'm going to change the style so it's existing. I get that red dashed look. And I'm going to draw in the profile view, and I'm going to use this is going from left to right, so I'm going to use left to right for this one as well. Create the profile view, and I'm going to put it directly below here. So there's the existing ground through the gutter. Okay, I don't need these white labels. You get them by default. So that's what the existing ground. Now notice the distance from here to here. I'm going to project down. I'm going to draw a line from here straight down. And I'm going to draw a line from here straight down. And if I take this and I move it from here perpendicular to here, you'll notice that the length along the center is shorter than the length along the gutter, which is exactly what you expect. Right? The gutter length is longer than the center line length. And that's why the center has to be steeper than the minimum gutter grade. Right? So this is the run for the slope along center, and this is the run for the slope along the gutter from here all the way to here. This is the run on the gutter. Okay. Now I need to project a couple of points from the plan to the profile. Before I do that, I need to have a preliminary sense of what the design surface is for the road. Right. So I need to create the road for the corridor model, which I haven't done yet. Right. So I'm going to go back to, because it's frozen, I'm going to go back to Tool Space. Prospector. I'm going to go to the corridor, right click, go to Properties. I want to create the surface for the road. Okay, so if you haven't done this yet, I think we did already, but if you haven't done this yet, this is how you create it. Let me recreate it from scratch. I'm just going to delete it, right? So when the first time you do this, there's nothing there. So it's 2 buttons. Click this first button, that creates the surface. Click this plus sign, that adds the data to the surface for building. Okay, and use them as break lines. Say OK. Rebuild the corridor. And now you have a surface from the corridor. If we want to look at it, it looks like this. Right, this is the corridor now. Right, here's Ledger Way, here's Street B, and here's Street A through here. So what I'm going to take advantage of is, okay, so keep that surface in mind. Let me get rid of the view. I'm just going to make it no display. Although the surface is incorrect here, at the beginning and at the end at the gutter, the elevation is correct. So this point here, I'm going to put an AutoCAD point here. And this point here, this is the profile position, this station on this road, right, on this gutter, sorry, this alignment, this position on this alignment, this position on this alignment. These are the 2 stations of the beginning and the end of the profile design of the gutter. And the elevation for these 2 points comes from the current road surface. Everything between these 2 points along this alignment is wrong, but at the beginning and at the end, they're correct. So I'm going to project these 2 points to the profile of this alignment, and the elevation of these 2 points are going to come from the road corridor surface model. And that is the station elevation and the station elevation of this gutter profile. And magic should happen. Well, not magic, you did it on purpose. It should be steeper than what? That design profile of the gutter should be steeper than what? Remember the value of what the gutter needs to be as a minimum? 0.75%, exactly. So when we see this profile and its design slope, it should be steeper because we rounded this number up a little bit, right? It should be steeper than 0.75%. So when you see that, it verifies your design is correct for the center line, and it should not be a surprise. If it doesn't come, to be a little bit steeper than 0.75, you know you did something wrong here. Okay, so it validates what your design for the center line should be, because now I should see something at least 0.75%. So let's do this. So we're going to go to project the points. So take this point and this point, enter, bring them over to the gutter profile, click, and now don't accept 0. Set the elevation from the corridor surface. Say OK. And now you've got the 2 points of reference that represent station elevation, the 2 PVIs for the gutter. Let me get rid of this. So all you have to do now is create a design profile that connects those dots. So we go to Profile, Create Profile from Layout. I'm designing it. I want to be in charge of what that design is going to be, not the surface, but the layout. Click on the grid, give it a name. So I'm going to give it the alignment name, which I cut and paste from before. FG, the finished ground of the gutter. Say OK. You get this dialog box. We're going to take this PVI generator. I'm going to start here, node. I'm going to go to here, node. And when I hit enter, you're going to see the labels. Okay, and I'm not crossing my fingers. I expect to see 0.75%, a little bit steeper. And there it is, 0.8%. So that's not a surprise. That's what I expect, because I know I designed the road correctly on center in the profile above. So now I have my horizontal alignment for the gutter. I have my vertical alignment for the gutter. I need a correction, an assembly with subassembly parts. So now you have to remember the alignment in the plan, what it represents. And if we go back to the standards, so far, right, this is E2, whoops, E2, right, E2. So far, I built 2 assemblies where the reference point is the crown of the road, right? Now, the alignment that I drew on the gutter represents this position right here. So I need to build an assembly with sub-assemblies that have an asphalt pavement and a gutter line on one side of center, and then a face a curb, a top a curb, and a boulevard on the other side of center. This is the reference point now, not the crown, not the crown. Okay, and there's an option. I can use this reference point for the gutter, or I can use this reference point for the gutter, right? Do I put the asphalt on the right side of the gutter or on the left side of the gutter? Any ideas? Do I build it the right side or the left side? Is the boulevard going to be on the right of the gutter, or the boulevard going to be on the left side of gutter? And the secret to that, or the reason for that, is this. Remember this? The direction of increasing chainage is this way, which means this boulevard is on the right side of this alignment, right? So I'm going to be creating it to look like this, not this. If the chainage was 0 at this end, increasing in this direction, then the boulevard would be on the left. But I'm going this way, so I need the boulevard on the right. Okay, so you have to be consistent. You have to make sure you know which is the left side, which is the right side, which is something I know in highways, right? Left and right side of cross section, how it's defined. Stand on the road, look in the direction of increasing chainage. Your right hand is the right side of the road, your left hand is the left side of the road. Okay, we teach you that for a reason, because now it comes into play. You need to know that this boulevard is the right side of this alignment based on the chainage increasing in this direction, right, from top to bottom. So let's build that. All right, so right near here, I'm going to build that. So I'm going to go to corridors. I'm going to go to my tool palettes. All right, so I need to look at my link width slope. This is the only one I have ever used. That's the only one I've shown you. Okay, there's the other one in highways where you have all the layers of the different pavements and stuff. I'm not interested in that. I just want to know the top surface geometry. So I go to corridors. I go to create assembly. Give it a name. This is going to be called Boulevard on the right side. Okay, I can't spell gutter, sorry. Gutter Boulevard right. Say okay, pick a point, it's going to zoom in on it. Okay, so now I'm going to have, on this side, I'm going to have gutter and pavement. So I'm going to click on link with slope. On the left side, I'm going to have a 0.3 meter wide, 0.3. Try that again, sorry, link with slope. Now, if it doesn't let you change this value for some reason, this is a hiccup we've had before. This should be 0.3. If it doesn't let you type in here, and it's not letting me type in here for some reason, just accept it. Just draw it and make sure it's on the left side. So I'm going to draw 2 on the left. 1, 2. They're both wrong, but I've got 2 pieces. Now I can go and revise them. I don't know why that's not working all the time. Some of you may have experienced that as well. So this piece is the gutter. Is it going to be... Now I can go to change properties, and now I can actually change the parameters in here. So it's only supposed to be 0.3 wide. And is the slope positive or negative? 8.3333. Is this positive or negative? It's going to be positive. I'm coming up out of the gutter. So this has to be positive. So there's the gutter. This piece here, I'm just going to change the width. I'm just going to change the width to 1 meter. And I'm going to leave it at 2%. And the other thing I'm going to do with this piece is I'm going to change the name. I'm going to call this pavement. And that is the needle in the haystack I need to find later for targeting. Okay, so that's the only one I'm going to change. Now I need on the right side, so now I use this again, link with slope, change this to right. But it won't let me type. I don't know why. It won't let me type the number, so just produce it. I need the face of the, whoops, drew it on the wrong side. Do that again. It won't let me, it needs to be on the right, but it won't let me change the width. So just produce it and then revise it. Don't pick the cyan circle. Start in the center of the road. So 1 there, now pick the last circle on the right, now pick the last circle on the right. So I need face, top, and boulevard. Face a curb, top a curb, and boulevard. Don't need this anymore. Change properties of this. This should be 0.05. Now let me zoom in so you can see it happen. 0.05 wide. And the slope is 300. That's the face of the curb. This is the top of the curb. It's only 0.15 wide. It's perfectly flat, 0. And then this is the boulevard, which should be 2%. At 3.5 meters, same as the typical boulevard, right? Same as this boulevard on a 16-meter right-of-way, right? 3.5 meter boulevard, right? And now my reference point is here, right? Is right here instead of the center of the road, right? The green line is now here on this assembly that I just built, right? So this should have been 3.5. Let's just check it again. Sorry, 3.5. So now I have a horizontal alignment for the gutter, I have a vertical alignment for the gutter, and I have an assembly or a cross section for the gutter. Okay? I want to add that to the model. To add that to the model, I need to first, like a surgeon, take out the bad piece, cut that out, and then splice in the correct piece. So to do that, I'm going to go to my corridor. Right? I need to split the region. And the region splitting happens between these 2 points. Okay? And when I come around here, I want the right side of a typical cross section to disappear. But I want to maintain the left side. I want the left side typical. So now I need one more subassembly. I need a typical cross section of 16 meters. Make a copy of this. Right? Move it down here. And I want to drag not the full section around the curve, but the half section, just this. So when I split the region, this is what's going to happen, right? I'm going to change the name. So it's a typical 16-meter righter, left side only. Okay, so when I go around the curve, I'm going to replace this with this. And then on the gutter, I'm going to add the center, the profile, and the cross section of the gutter. Okay, so I got to splice out the bad and bring in the good. So before we do that, I have to split the regions. So on this profile, on this corridor, let me show you from out here. I'm going to go in and out a couple times. So once I click on the corridor, right click, go to corridor properties. Okay, and if you go to the parameters, when you click on the, let me collapse all of these. When you click on the baselines, it'll highlight the center line of the one that you've selected. What? So I'm going to click here. See, that's the center of Ledger Way. Here's the center of Street B, and here's, Street A, and here's the center of Street B. So those are the center line baselines. If you expand these, if you touch the region, you'll see a perimeter of the region, right? So highlighted in blue. So that's the entire region. There's the entire region for Street A, and there's the entire region for Street B. I'm going to splice out or split just in this elbow. So what I do here, you have to do again here. Okay, so I'm only doing this elbow. You need to do both, okay, but I'm only going to do one. So I'm going to take this, I'm going to right click, and I'm going to say split region. Give it a minute, it's thinking, and now you have to snap exactly to this node or this end of curve, right? So this node, NOD, and this NOD at this end, NOD. And now because I'm done splicing, right, I'm going to hit enter, and it's going to turn what used to be one region into 1, 2, 3 regions. Right, so now I have 3 pieces. Before you do anything else, complete this splice process by saying OK and rebuild. OK and rebuild. And now you've completed the splicing. If you don't do that, if you start making changes immediately after the splice without rebuilding the corridor, it loses its brains. Okay, it's not very cooperative. So I always splice, rebuild, and now I go back in and change the parameters. So now if you look at this, again, I'll show you from up high. If I go back to my corridor properties, right, if I click on this, you'll see the entire center line of Street B, but now I have 3 regions. There's this one up to the beginning of this curve. There's this, the curved piece, and then there's beyond that, the rest of it. Okay? When you're done, you'll have not 3, but 5, right? One that takes you to here, one around this curve, that's 2. One that takes you to this curve, 3, 4 for this curve, and then 5 for the end. So you'll have 5. I'm only going to do 3 though. I'm not going to split this region. I'll leave that up to you. So this is correct. That's your typical, right? But I'll fix, you're going to fix this elbow, so I'll leave that up to you. This one now has the wrong cross section. I should have a half section, not a full section. So I'm just going to switch this out. Instead of a 16-meter right of way, I'm going to drag the 16-meter right of way with the left side only. I'm going to say OK. I'm going to say OK. I'm going to say rebuild. And if you zoom in there, you'll see this half of the road is gone. And that's exactly what I did, right? So this is typical 16. I want a full section, a half section around the curve, and then a full section going forward. And now when I add the baseline for this piece in the middle, it'll fill in the blank with the correct thing. Okay? So now I have to add another baseline. So I'm going to go back to my corridor model, go to corridor properties, and add a baseline. The center line of the road, or the center line of the alignment, is the gutter. Say OK. The profile design is the FG, not the surface, right? You can go back and rename this if you want under alignments in the prospector. So it's the finished ground. And then I want to right click, add a region, and drag the boulevard around this. Okay. Say OK. Say rebuild the corridor, and it'll put it in. Looks crappy because I get a default for the frequency, so I have to change the frequency. Take this again, and I'll update all my frequencies. 3 meters for the tangents and 1 meter each for the curves. Say OK, say rebuild the corridor, and now it looks like a curve. And now you can see the gutter line. The gutter line is exactly where it's supposed to be. Whereas in this elbow, the corridor gutter is not where it should be. But in this one, it's exactly where it should be. And that's the whole point of the exercise. The last piece of the puzzle is to close the gap here. I want to take that little pavement piece. Remember, I renamed it, and I want to target the center line. I want to extend it horizontally to meet this alignment, and I want to match vertically the profile of street B. And this is the targeting part, right? So back on the corridor, right click, corridor properties. I'm going to go to this region, and if you scroll over, you'll see the targets for this region, right? Notice it's highlighted here, so you know what's going on. I want to click on the target, and I'm going to find that needle in a haystack. There it is, the pavement. That's the piece from the subassembly that's the edge of the asphalt piece, right? So I want that to have a horizontal alignment target of street B, right, the main road. So add that, say okay, that's the horizontal target. And then the vertical target, same piece. I want the street B center line of road design. Say okay, rebuild the corridor, and it fills the gap. And now I've got a true model of the widening, pavement and all. So if you have any elevations now required for the street line, if you have any maintenance holes, you can get the elevations for the top of the maintenance hole and the center line. Okay, there's still some housekeeping for the corridor. I'm going to show it to you in a moment. You're going to see some weird stuff, but we'll fix them together. Any questions so far? That's review, and it's worth reviewing. This is the part of the course that I like the most, because I've said this before. I wish I could teach this to you after you've taken it. And right now I'm teaching you something that I know I taught you before, that I know you've practiced before, but it should make a lot more sense this time around. And that's why I like reviewing it again, because it really emphasizes the concept, the idea, how to do it. And you should be doing a lot of head nodding, watching. Oh yeah, that makes sense. I remember that. Yeah, that's great. It's exactly what I remember, right? I did that. Yeah, so I know exactly what he's talking about. So this really emphasizes what you're supposed to be doing. Does it need to match the property as well, or can we just increase the length? Yes, that's a good question. That's part of the housekeeping that's coming up, Ziaro. So let me demonstrate that. That's exactly what I'm going to do next. Okay, so let's look at the corridor model. You're going to see some funny business, okay? So I haven't looked at it in 3D yet. So let's look at this corridor model in 3D. So select it and say Object Viewer, okay? And watch what happens when I turn this in 3D. There's a whole bunch of spikes. You see that? A whole bunch of spikes. There's a spike at the beginning of Street B at Ledger Way, right there. There's a spike at the end of Street B where it meets Street A. And there's a spike at Street A at this end. And there's no spike here. For some reason, there should be, but there isn't. It's fine. And then you have two spikes on either side of your gutter, beginning and end of gutter alignment, okay? The reason for these spikes is because when you build a corridor, the build range is the horizontal beginning and end station. But because the profiles are designed within that range, right? Your profile starts after the horizontal alignment and ends before the horizontal alignment. If there's no elevation in the profile at the limit of the horizontal range, it's going to assume the elevation is 0, right? So what am I talking about? Let's go look at Street A and you'll see exactly what I'm talking about. So this is the profile. The elevations for the corridor come from here, but it builds to the limit. This is the limit of the horizontal alignment. Well, there's no design there. So it assumes everything past this point here, because these are elevations, everything past this point here between these two stations has an elevation of 0. And that's why you get those spikes. So what you have to do now in the plan is grip edit the edge, the limit of the build, so that it comes into the profile range. Okay, so you want to start building your corridor here, not here, right? Or end before you get past this point. Okay, so Street A looks like this. I'm going to take Street A, it's all the way to here, this grip. I'm going to pull it back. It should coincide with the center line of the road, right? This point right here, the node. Right? So if I do that, if I look at this in 3D again, there should be no spike at the end of Street A where it needs to be. Right? So there should be no spike here anymore. Right? It's gone. You can see there's no spike. Now, there's a lot of overlap. You can see here, there's overlap between Street A and B, this T intersection here. So besides that, there's actually a better place to stop the build. Okay, and this is some lot grading information. If you look at this curve and this curve, right, which is the street line of the lot, the elevation for this point comes from this road boulevard. The elevation from point comes from this road boulevard. And the elevation for this dot and this dot come from the boulevard on street A. So really, we don't need to overlap the models. We can actually take this grip and not stop it there, but go outside the limit. Like, don't cross street B, leave a gap, right? Leave a gap between the end of this one and this edge. Okay, as a matter of fact, you can go even further. You can go as far back as long as you don't go past this point or this point, right? So on this side, it's not good, right? I want the model to go past these 2 points. So I'm okay on this side, but not on this side. So I'm going to grip edit this again and make it a little bit longer. And now I've got coverage here. Whoops, too much, my O snap. Sorry, let me do that again. Turn my O snaps off. All right, I'm going to grab this again and bring it forward. Right, so now this point is on the boulevard model here, and this point is on the boulevard model here, and these 2 points, one here and one here, come from this road model. Okay, now the intersection is not modeled correctly. There is no boulevard across here, but I don't care at this point. I'm going to leave it because all I want this surface for is to get the elevations of this corner and this corner, and this corner and this corner. Okay, so keep them from overlapping, but make sure that all these corners on each of the corner lots is covered, right? Is in the range of the surface. I'll show it to you again. The same thing happens here, right? These two. This elevation comes from street A. This elevation comes from street A. These two, this one and this one, come from street B. So if I click on the corridor model, I don't want them to overlap. I don't want them to overlap. I don't want them to overlap. But I want to make sure that this dot and this dot are within range, right? So I could go a little closer, I could go a little further, but I can't take this back here. That's too far, right? Now this point is out of range, and this point is out of range. So I want to bring it forward a little bit more. And now from this surface, I can get this elevation based on this road boulevard and this elevation based on this road boulevard. Same thing at the entrance. Right? I'm going to pull this all the way back to here. Turn my ortho off, sorry. All the way back to here. Right? You don't want the roads to overlap, so you should see a gap, right? Object viewer. You should see gaps, right? You don't want this corridor piece to go across this one. So you want to leave a gap, but you want to make sure you're far enough so that this point and this point are within the range of the street A piece. And this elevation and this elevation will come to ledger way. Okay, and if I look at this, there's two more spikes. This one here, object viewer. All right, so I got to do the same here. Now it doesn't matter that this is here because I'm not doing any work here, but I always like to tidy it up for the same reason. So I'm going to take this corridor and I'm going to grip edit this back to here. Okay, so now there's a gap between Ledger Way and Street B, but you can see the points have coverage. This point from this boulevard, this point from that boulevard, this point from this boulevard, and this point from that boulevard. Okay. The last spikes, object viewer, are on the elbow, right? On the elbow. Okay, and again, I'll show you. You don't want this to build. If I click here, see this grip? That's the end of the horizontal alignment. Well, the vertical alignment ends where this green point is, node. So it should stop there. And on the other end, right, the corridor is building here. It should start building here, node, that green point. So now I've got my build to coincide with the profile range, not the horizontal alignment range. So now if I look at this in 3D, object viewer, no more spikes. Okay, don't forget to save your work on occasion, because if you crash, you're going to be very upset. Okay, so this is almost ready to go. Okay, you should get this far, plus you need to model this elbow. You need a horizontal alignment, you need the vertical alignment, and if you create your alignment to start 0 here, increase in this direction, parallel to center, you can reuse this assembly, right? Because the boulevard's on the right for that curve as well. If and only if 0 is here and it increases in this direction, that makes this boulevard the right side. Okay, so I'm not going to do this one. I don't want to waste time in class, right? I've done one, you should be able to do the other. And if you still want to practice, you might as well do this one too, okay? But this one is not necessary for our design. If you don't do this one, I'm not taking marks off. But these two are definitely required. The last tip in the housekeeping is, again, what I said before. Remember, if you have an open net, this hockey analogy, if you have an open net, never aim for the post, right? Never be on the edge of something. So this is where you do one last thing, and it's obvious in the elbow. You'll notice my surface for the corridor, the edge of the surface, doesn't go all the way to the street line, right? Because this boulevard is a little bit atypical as well. So you have to be careful. What you need to do on the cross section is make the boulevards all a little bit wider, right? The street line, you'll notice, the street line is right on the edge of the corridor, exactly 16 meters wide. I'm going to take the boulevard, the plane of the boulevard, 2% plane, and make it a little bit wider. I want to extend into the lot a little bit so that the lot corner is not on the edge of the right-of-way, but inside the right-of-way model. Okay, so now I'm going to go to all my boulevards, and I'm going to do this for Ledger Way as well, right? If you look at Ledger Way, if you zoom in here, right, this elevation might be outside the range of this alignment. You got to be careful, right? And it's obvious on the curves. If you go to one of the curves, especially the outside, I need the elevation of this point. And if you zoom in, you'll see the corridor model doesn't go quite that far because I'm mimicking a curve with a straight line. What's happening is this. If you have an arc and you're mimicking the curve, you're actually getting a bunch of chords. Nearest, I'm just demonstrating the problem. So if I go polyline, if I go from here to 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 here, it looks like a curve, right? That looks like a curve. But if you have a line that goes from here perpendicular to the curve, right? If I want that elevation, if you zoom in, you'll notice the street line is not where the corridor. This is a bunch of chords, but now this is out of range. And this is typical of the outside of the turn. The inside not as critical, but the outside is a problem. So basically, the short of it is you have to make all your boulevards a little bit wider so that they extend into the lot. That way, the corner of the lot at the front is inside the definition of the boulevard, not on the edge of the boulevard. So we go back to here, and we're going to make these a little bit fatter. So I'm going to just add about a ½ meter. I'm going to take this, add ½ meter. So instead of 5, I'm going to use 5.5. I'm going to make this one, because this is not symmetrical, I'm going to make this one 5. And then I'm going to go to all of our boulevards, right? This one, and this one, and this one. These are all the same, 3.5. And even the one that on the gutter. They're all 3.5. I'm going to just make them all 4. Okay, and if you do that, and you look at your road now is saying, hey, I'm out of date. You changed some of the data, so you have to rebuild your corridor. So let's watch this happen. Okay, so let's watch all your boulevards get wider. Right, so I'm going to rebuild. Watch, it's going to go, it's just going to get a little bit fatter. See that? It just went to the outside a little bit more. Might not be enough. Double check. Did this one get wide enough? No, this one's still no good. Ugh. So I should make this boulevard wider. So instead of adding ½ meter, I'm going to add a whole meter. Okay, and this is something you need to keep in mind. 1, 2, 3, and this boulevard here. Change. And I'm going to go to the boulevard definition. I'm going to add another ½ meter. So instead of 3.5 to 4, I'm going to go 4.5, an extra ½ meter, just on the 16 meter right-of-ways. Okay. I think Ledger Way is okay, right? There's the street line. Ledger Way is wider. There's the street line. Ledger Way is wider. And let's see it happen here. So let's rebuild the corridor. Rebuild. Watch what happens right here. And now the corner of the lot is inside the limit of the 2% plane of the boulevard. All right, so it's okay to be a little bit wider than it needs to be. That way you have full coverage, right? Never design to the edge of something. Always look at something within the limits. And that's just a general comment about most of the work we do. Okay, When it comes to here, I'm going to give you a preview. When it comes to here, this boulevard must extend all the way to this point here, because you want a 2% plane in this triangular area. So this boulevard needs to be about this wide from the back of curb, once the back of curb is established, all the way to here. This elevation, where my cursor is, comes from the corridor model of street B. Okay, this elevation comes from existing. We'll deal with that later. Okay, but you have to extend all the way to here. And that's a bit of a head scratcher. I'm going to leave that one up to you. Okay, so make sure you extend this boulevard wide enough to get to here. And you may only have to do it, because you're coming around the curve, you may only have to adjust this, make this wider, because this is what you're going to drag around that curve, right? You don't have to worry about the typical sections. You can leave these ones alone. All right, any questions about that? Okay, what time is it? It is 3:07. Do you want to take a 13-minute break? We'll come back at 3:20. Who wants to take a break? Okay, so we'll take a break at 3:20. It looks like everybody wants a break. So I'll see you at 3:20, and we'll start our discussion about lot grading. Thanks, okay? See you soon. Bye. Okay, we're back. So let's continue this discussion now as far as the lot grading is concerned. Okay, so there's some information here that's got to be, you have to figure out the source of the data. So let me bring up my screen again. Excuse me. Share screen, entire screen. Okay, so here's my subdivision. So this is where we left off. Now you remember this, whoops. Let's check that again, hang on, Tron. What I would do, Trung, is the same way you did this, I would do this. So you're going to have to split the region, replace the full section with a half section on the inside, and then add the baseline, the profile, and the cross section for the elbow. And then all you need to do is make this elbow, sorry, this boulevard long enough so that the corridor model extends all the way past this point. So the corridor model, right, this boulevard has to get wide so that you've got coverage here. This point has to be within the limit. Now you only need to widen the boulevard of the elbow, right? Not the typical, right? Don't widen these ones, just this one. It'll widen this one as well, but that's fine. Okay, does that answer your question? Okay, so you'll see when you splice this one in, the boulevard won't be wide enough. It'll look something like this, a little bit wider, but it won't be wide enough. Okay, so I'll leave that up to you. I think I've explained it, but you need to figure that out. All right, so now to do your lot grading, you need that condition, right? Once these are all done, I don't need these anymore, right? These were just some of the tools I used to do my profile design. I'm going to get rid of my corridor model. I'm going to freeze it. Okay, so to do the lot grading now, I need the proposed elevations at all my front lot corners. So I prepared a layer, right? This is something you need to do. This is review again from CDA. So we look at C, where is it? C front proposed. Do you remember this? This civil on the road in the plan, the front proposed elevations. So that's the layer you should put all these elevations. So there's a PDF that shows where you have all your front lot corners. These are street elevations. All these elevations for the front lot corners along the street line come from the corridor model. Okay. Now, if you want, if you created the alignment for street for Ledger Way and it's on your corridor model, then you can do the same for these. You can make a copy of this and put it here and here and here and here and here. Okay, so all those street line elevations. Oh, I missed a couple. Here, I could put one here, and I can put one here, and I can put one here. Okay, so these are all front lot corners that you can get from the corridor model, right? Including this one, right? So that's why you have to be wide enough here. Right, all your front lot corners. So there's a diagram of all these front lot corners in a PDF that was given to you by Professor Neruzzi. So it looked like this, I believe, right? So he gave you this. So you can see everything in red, right? F, G comes from the corridor. So anything you see in G. Now, because we have a corridor model for Ledger Way, you can actually do the same. So this blue one, this blue one, this blue one, and this blue one, they can actually, instead of interpolated, you can get them from the corridor model. Only if you modeled Ledger Way on the corridor model. If you didn't do that, then you'll have to do what you're doing back here, because we don't have a corridor model for this road. Okay, so this now, if you have Ledger Way, can all come from, even this lot corner, this can come from Ledger Way, okay, because it's part of the edge of Ledger Way. But everything else inside on the street comes from the corridor model. Okay, so once you create the layer, right? So I created the layer for the front lot corners. I placed all the points where they need to go, right? And I already rotated them. You don't have to, but you're going to eventually have to rotate them, right? So what do? You click on one. You right click, select similar. That selects all the street line elevations. So this is from my legend. I don't need that one. Sorry. Get rid of you. Okay, so I take that right click, select similar. So these are all the elevations at the front, at the street line that come from the corridor model. So now I can just right click, elevations from surface, and then choose the road surface model and say OK. So now all those elevations have the correct elevation from the corridor model. Okay? I'm not showing them to you because you're going to get whatever you get. Okay? So there's no, I'm telling you the source. So it's up to you to get those elevations from that source. Okay? And those numbers are what they are. Okay? So I'm not going to show you what they're supposed to be. I want you to determine them for yourself. So you'll see them. Right? So my point label is just a constant that says FG corridor, right? Instead of the actual elevation. And they all have a description, FG, and they're all going to be in my point group called FG. So I'm going to create a I'm going to create a point group, properties. I'm going to create a point group. It's going to be FG. I'm going to include anything that says FG. And what's it going to look like? It's going to look like a point, and it's going to look like an elevation. Okay, so if you're a member of this group, it's going to look a certain way. Use the styles that you had in CDA. Okay? And if you don't remember what they are, go back and look at your CDA reference documents. Right? So these are all posted online. So if you go to project files under the CDA reference stuff, you'll see in here, view details, right? How to create points and label styles. So that's how you do it. And what do I want to use? Go back to CDA, whatever the styles were for proposed and existing that you used last semester. So you can open up your old drawings, look at those, or you can look at the assignments from last semester. Okay? So proposed is proposed and existing is existing, just like before. Okay? So I expect you to be able to create the groups, create the styles, make sure the points are in the group and so on. Okay? So that's the front lot corners. And notice I did all of those elevations for all the streets one shot. And that's why, and I've said this before, that's why I have one corridor model. And then I have one corridor surface, and I can create all my elevations at the front lot corners and get all the elevations once and for all at one time. If you have a corridor for street A, and you have a corridor for street B, and you have a corridor for Ledger Way, and you have a corridor for each of the roads, then you have to do that function for each road. And you have to have a layer for the front lot corners for street A, and then you need a separate layer for the front lot corners of street B, and C, and E, and Ledger, and whatever else you have. This way, you have one model for all your front lot corners for the entire subdivision. And that's why I have only one corridor. That's why my corridor is called roads. All the roads, one model. Okay? So that's the advantage of it. That didn't make sense last semester because we only had one road, but now we have two. And you can see if you have 3, 4, 5, 6, as many as you have, put them all in one corridor model. The only limit to that statement is if there's a lot of roads and the file starts to get too big to manage, then you might want to create two road models, a north and a south, or an east and a west of part of the subdivision. Right? So then you may have to break it up into two parts and into two different drawings because the file size is getting too big. Okay? We're not running into that because I'm keeping things relatively small in terms of the data set. But you can imagine if you're looking at this, if you remember, think about the scope of what we're doing. If you think about the general model for this subdivision, right? Look at how many roads are here, right? For this size subdivision, I might still have one corridor model with all the roads, including all the elbows and so on, right? And crescents and cul-de-sacs and whatever. This might be manageable as one model. If not, you might break it up, east and west, north and south. Okay? But I certainly wouldn't do one road at a time. I would try and keep as many as possible. Okay? Otherwise, it's a lot more work to get those elevations that you need. Okay, so I hope that makes more sense this semester. I know I said it last semester, but it was trivial. We only had one road. But if you can put them all into one model, then you can get all the front lot corners for your entire site once and for all, which is a pretty handy tool to have, right? Do it once and you're ready to go. So now you have all your front lot corners. The next, I think I posted in the project files. So if you downloaded the project files with the template and so on, you'll have another file called a topo CSV. Okay, it looks like this. So you might have had in the project files, right, in the zip file that you downloaded, project files, you should have this, topo points, CSV. So now you need to import those points. First thing you want to do is create a layer for existing elevations. So I'm going to create the layer for existing elevations. It's called C Road Plan Lots Existing, EXTS, right? Remember, it's always 4 letters, dash 4 letters, dash 4 letters. So that's the current road. Then I want to create a point. When I do this, the points are going to come in on the current layer, and I want to put them in a certain group, okay? And I'll do that after. Or I can do it during the import command. So I can go to points, create points. This button here. I want to select the file name, so it should be in, should be in where I download, on my desktop, under my course code, under the downloaded files, under project files, there's the file, right? If it doesn't come up, make sure your file type is set to CSV. If you set it to all, you'll see all the files, then you have to go looking for it. But if you want to narrow it down, change your file type to SVC or CSV, comma separated values, open it. So there's the file. The file format I'm only ever using once is this one. There's only the one I ever use. There are others, but I always use this one. Point number, northing, easting, elevation description, comma delimited. You'll see a preview here. Okay, and now when you import them, you can actually put them directly into a group through this function. So we can go to add points to the group. And instead of FG, we're going to create a new one using this button here. It's going to be called EG for existing or EX for existing. Say OK. And it'll put them in the point group based on the point numbers. I'll show you that after it's created. Say OK. And it imports the points. And you'll see this fuzzy thing around the perimeter. Whoops. Sorry, this is the existing. My bad. Sorry, wrong one. Wrong file. Wrong file. That's what we did for the topo. What you need, I can't remember if I posted it or not. No, I haven't. Okay, so you need, I haven't posted it yet. I've got the perimeter grades. Maybe I posted them. Let me just check the website, just a second. So back to here on the website under municipal, under course documents, you should have in here. It's not in there. Okay, so I have to post it. So it's called, I'm going to post the file right now before I forget. So under Seneca, MED, submission, project files, type. So you need this existing grading perimeter. So that's the original design around the perimeter. So this is the one for the topo, my bad, this one here. So I'm going to post it. There's a new CSV file. So there it is. Existing perimeter grades. Okay, I'll show you what that looks like when we bring it in. Okay, do that again. Where's the file? Hang on a second. I want to keep an eye out here. Okay, so where's the file? So once I downloaded it, right? So download it with all your files. I actually have it on my local drive, so it's under personal Seneca MED project file. So it's going to be called this existing grading perimeter. Say open. Choose the file type. It's the same. Format is the same. And there you've got everything, and you'll see they're all EG. So you have a couple of choices here. You can add it to the group called EG, and it's going to do it by point number range, which is fine. But I'll show you how to change that if you want. All these are called existing. I say existing. What I really mean is the previous design, and I'll show you the PDF that comes from. Right? I'm going to say OK, and now you should see. It's going to ask you if the point numbers match. You want to check it. Just say apply to all duplicate point numbers. Say OK, and you'll see this fuzz around the perimeter. See those points all around the perimeter? Select similar. You're going to get the previous design, and we're going to pretend they're existing. Right? You have to match whatever was there before. Okay. To get that information, where did those numbers come from? I'm going to give you some information here where the source is. So if we go back to, you can download this file from the website under the grading model. Right? You can see the entire subdivision, but the grading plan. This is available for download now. If you zoom in on this design, you'll see. Let's look at this one. On the perimeter, you'll see proposed, and then in italics, existing elevation. So this is the proposed design, this is the existing. This is the proposed, this is the existing. I digitized all the proposed. So look at the, so here we are at the bottom left of our site, right? This is our site here. This is Ledger Way, right? This is Ledger Way, this is Chuchmak, our site's right here. So if you go to the bottom left right here, you'll see the proposed elevations, right? 196.20, 196.03, 196.85. Let's go back to the drawing. 196.2, 196.03, 195.85, right? 03, oh, that one's wrong, actually. It should say 20, not 02. Good thing I checked it. This one should say 46. I think I have a typo. This one should say 46. Yeah, so this one came in. It's actually wrong. This should be 02. Should change that. The rest, though, come from that source, right? So if we look at this corner, you should see 377 and 4.1. Back to here. What's the chances of zooming in on a mistake I made? That's what I did. Okay, so you can see here 410 and 377. 410, 377. So I digitized all the points around the perimeter, and I obviously did this one wrong. So it should be 02, not 20. Right? So I've checked it, but I obviously made a mistake. So, oh no, it's right, 20. That's correct. 20, I did it right. 46, 20, 03, I did it right. 46, 20, 03. No, it's correct. It's correct. All right, so those are the perimeter grades. So I took the time to digitize. What I did is I placed all the points in the plan at the correct place based on this drawing, and I typed in all the elevations. So basically, I digitized the perimeter elevations all the way around the site, created a CSV file. So you don't have to do that. I've done it for you. All you have to do is import it. So when we do our design around the perimeter of the site, it has to match those elevations. Okay, so that's all you need to do is import them. So that's the design. What we need to do now is respect that elevation across the limit, right, or across the edge of the site. So to do that, we're going to interpolate. Okay, so I'm going to show you one more tool, which I didn't show you last semester. This is what I told you to do last semester. Watch. So I want the elevation on this corner and this corner, and it's going to be between these 2 points, because these 2 points, right, these dark blue points are between these 2 points. So these two are going to be interpolated between these points. So I'm going to turn my OSNAP to node and to endpoint. And here's what I taught you to do last semester. First thing we do is go to inquiry, and we list the slope. And then P, enter. The slope between here and here in this direction is negative 0.9, right? So from here, it's negative 0.9 to here. So what do? I use the distance command. I'm going to go from here, endpoint G minus 0.9. Distance, I need the endpoint again. Enter, enter, enter. And do it again from here to here, G minus 0.9. Distance, pick again, enter, enter, enter. So now I've designed these two. Okay. Now I want these interpolated values to be on the existing, on the rear, proposed rear. Even though they're the same, right? They're matching existing. I'm going to use not lots existing, but I want to use rear proposed. So I want this the current layer, right? So I'm going to make this. I'm going to make this blue, right? Just like the drawing, right? So these should be on this layer here. Just going to draw a line and match the property. This match these, right? So these are interpolated. You can update your point group, and they should also be FG, because I want my front lot corners. I want my front lot corners to be on one layer. I want these interpolated values to be on a different layer, but I want them to have the same description so that they all go into one group, proposed grading. Okay? So that's how I taught you how to interpolate last semester, right? Measure the slope between 2 points, and then you could use that slope in between. Okay? Watch this. Here's the new tool. This is the next tool I want you to see. I'm going to move these over. Okay. Here's the other tool, right? So in here I taught you, whoops, in here, points, create points. So I taught you how to use the high-low and the distance command, these two. Okay? Those are the ones you used almost exclusively last semester. Here's a way of interpolating directly. Not this button, but the next one to the left, by location, relative location. Okay? This will interpolate for you. So click on that and pay attention to the prompt. What's the first point? The order does not matter. If I go from here to here, it's going to be negative 0.9. If I go from here to here, it's going to be positive 0.9. So the first point doesn't matter. Okay, so pick one, pick the other, and then interpolate. So I want to go from here, and I'm snapping to the node. Otherwise, it's not going to read the elevation, right? So I'm going to click here. It's going to read that elevation. You have to accept it. So when you pick, you have to hit enter. Then pick the other one, and then hit enter again. You have to accept the elevation that it just read, enter. And now pick the spot. End point of this one, enter, no offset. End point of this one, enter, no offset. So now these two are interpolated between these 2 points. And you'll see the elevations match. 09, 09, 892, 891. Okay, so it's off a little bit, but it's close enough. Remember, we're doing this to 2 decimal places, not 3. So your design, you should change your style to show just 2 decimal places. So there's a new tool to interpolate. Okay, so let me do it again. So here's this. You look on either side. Look to the left, look to the right. This point's in between, so I have to interpolate between these two. So again, the command is relative location. Click, enter, pick the spot, enter, and it interpolates. Right? These two come from between these 2 points. So I'm going to interpolate relative location. So I'm going to pick, enter, snap, enter, and I'm done. And you're going to do that all the way around because you need to know the elevation of all of these lines at the back of the lots. Once you have an elevation at the front and you have an elevation at the back, you're going to go back to what I taught you last semester, right? What's the front elevation? What's the back elevation? What's the length of this line? If you have to use the spreadsheet, you remember the lot grading spreadsheet, go ahead and do that. You'll find most of these are going to be simple split draining lots. The only exception is going to be, I think, in this corner here. When you go around this corner, I think this, and this, or maybe just this, I'm just guessing based on my past kind of design of a different layout. You're going to find around this corner here, you're going to have maybe some back splits, right? So they're still split draining, but back splits. But the rest of the subdivision is going to be simple split draining lots. 2% up from the front, 2% up from the back, or 2% up at the front and 3% up from the back. Okay? So you have to go and interpolate. The only exception, like I said, is over here. These elevations could come from the corridor, but if you want, you can interpolate. Right? Remember, I got from the corridor. I'll give you a hint. Right? Lot 2. I'm going to list this. It'll tell me the elevation without showing it. So the elevation of this point is 195.02. That comes from the corridor. Let me interpolate and see if I get that same number. Should be close. Okay? So I want to interpolate between this one and this one. Okay, so points, create tools, relative location. So from this existing, enter, to this existing, enter, this endpoint, enter. So now it interpolated. That I got from interpolating. This I got from the corridor. Let me just check it again, because the label's not showing. So I'm expecting to see 195.03. I've got 195.00, so it's off by about 3 centimeters. So my corridor elevation is different than this interpolated value by 3 centimeters, okay, which is approximately an inch, right? It's not that big a difference. If I have a corridor model, I would go with the corridor model, okay? And the reason for it is, in this location here, there's a vertical curve. So if you look at the vertical curve, and I'll show you on Ledger Way, if I look at the vertical curve on Ledger Way, it's not really a vertical curve, but I'll show you. Okay. So if you're interpolating along here, you'll see this hump, right? So what happens on the street line is, if you project straight up, I'll get an elevation at a front lot corner here, and another elevation at a front lot corner here. And if you interpolate between these 2 lines, you're going to miss the details in between. So the corridor model is actually more accurate than interpolating, because if the front lot corner is here and the front lot corner is here, then when you interpolate in the straight line, you miss all the detail in between. There's more resolution on here than there is in the grading that I gave you, the points that I gave you in plan. If you're interpolating between here and here, then it's probably going to be very close. But if you're interpolating between here and you're missing all the details on the profile, then you're going to get something a little bit different. Now it's close. 3 centimeters is close enough. If you have the 2 sources, The more accurate one is the corridor, not the interpolation. Okay, and let me show you. Let's get away from here. Okay, this is where that curve is, right? The high point. Let me show you here. I'm going to interpolate here. This one should be more accurate. Okay, so I want to interpolate between this point and, between this point and this point, this corner here. Okay? I want to see how close I am to this one. So I'm going to interpolate between this existing enter on the end point of this curve right here, enter. So I've interpolated a value of 478, right? 194.78 if you round that. What's this one? It came from the corridor, right? So 478, 473. So it's off a little bit. Okay? So it's close enough for lot grading, but there might be a slight difference. Again, in the intersection, and let's go back to it here, which is approximately where these services are, right? Right in here, it might interpolate between here and here, and it might be a little bit off. Okay, so be careful. It might not be exact. They're close. It's not like they're planets apart, right? We're talking about a couple of centimeters, 2-3 centimeters, okay? In this case, when you have ledger way, you have a corridor model, and you have the points from the grading plan, the design points that should have come from a corridor model. If you have two sources, I would always err with the corridor model. Start with the corridor model and check it against the points if you want to interpolate. Okay, but they should be very close. If I had to choose one over the other, I would go with the corridor model, not the interpolated one. Right? And where you have no corridor model, you have to interpolate. Okay, so you have to interpolate everything across the bottom here, and you have to interpolate everything across the top here. The nice thing about what's happening up here is the proposed points are actually right on the mark. You don't have to interpolate. Okay? But you have to make a copy of these existing elevations and put a proposed point at the same spot. Remember what we did last semester? We got the existing at the back from the surface, and if we were matching existing, we had a proposed point of the same elevation. Okay, so the thing to do here, now we've got this interpolated. By interpolating, there's no distance, right? So I'm just going to take one of these points and bring it over here, and here's the beauty of it. Okay, if I take this, if I move this from node to node, the elevation will match. Two different points, right? Same elevation. So if you want the elevation at the back to propose, you put a proposed point with the same elevation. And if you make a copy of the point, from node to node, let's pick another one. You're gonna have to do it everywhere, right? Every lot corner, every lot corner, every lot corner, every lot corner. These elevations are now also proposed. That one hit the end point. My O snaps on end point. Just the node. Copy. Node to node to node to node to node. See, the elevations match. The elevations match. The elevations match. Why am I proposing? Because I want these elevations to be in my FG group, so that when I build my finished ground surface, I have elevations along the back. These points are not in the FG group. But if you copy and put them on a proposed layer with FG as the description, then they'll be included on the FG surface. These are here for reference. If I want that elevation on my proposed ground, I need a proposed point. Because this is not in the FG group, it won't be on my FG surface. Okay, so we did that last semester as well. So up here, you're technically interpolating where the distance between points is 0, right? You're not between 2 points, you're right on the mark. Okay, so make sure you do that across here. So interpolate across here, interpolate across here. Again, if you created the corridor model for ledger way, I would use the ledger way corridor. So what's shown on this, on this, where is it? This, right? These, there's actually one here. 1, 2, 3, 4, 5, 6, 7, 8 points can come from the corridor. It could be treated like the red points. Only if you modeled ledger way. All right, the colors for the layers based on the PDF image. At the end of the day, and this is for the last assignment at the end of the semester, I'm going to have different layer colors based on the source. So the existing ground gets its own layer. The proposed front gets its own layer. These interpolated values get their own layer. And then when you do your actual lot grading, right, between front and back, that's another layer, proposed lot layer, right? So there's going to be front proposed, back proposed, and then lot grading proposed. So you're going to have 3 layers for the proposed, but they all go into the same group. And then the existing has its own layer in its own group, just like last semester. You can have different colors here, but then if you remember in paper space, they'll all have the same color, even though they're on different layers. I like to keep them on different layers, different colors, and that way it's easy to tell whether you've produced it on the correct layer. Okay, so I'll go through this again next week when you have the design done, right? Some of the grading done, so that you can make sure you've organized it correctly. Okay, but it's the same speech I gave you last semester. Anything proposed goes in the FG group. Anything existing goes in the EG group. But the proposed points have different layers. Some are on the front, some are on the back, some are the points in between. Okay, and there's a reason for that, especially the front lot corners, right? You want to select just them, and you do it by select similar. What layer are they on? You want them all to be on the same layer. Okay. So once you've gotten this far, you can do the lot grading for everything from lot 1 all the way to lot 22, right? Because you'll have a front and an interpolated back, a front and interpolated back, right? So you can do all of this lot grading. Across the top of the townhouses in these 2 units, you'll have a front and a back, a front and a back, and a front and a back. So you can start doing this design, right? So this is just like last semester. You have a condition front, condition back. What do you do in between, right? You have a condition here where you have the front and you have a back. What do you do in between? Here are the setbacks. The front of the house is back 8 meters, just like last semester. Okay. And the house is going to be, what did we use last semester? 12 meters. So the house goes back 12 meters. So there's your zone for the house. Front of the house, back of the house. So use the same setbacks I taught you last semester. 8 meters to the front, and then from the front to the back, use 12 meters. So your split point has to be here or anywhere in between. Okay, that should sound familiar what I just said. Okay? The only piece of the puzzle you don't have is, what do you do back here? What happens back here? How do I get the elevations at the back? Because if I had the elevations along the back, then I'm in business. I have a front, I have a back, I have a front, I have a back, I have a front, I have a back. I know what to do in between. How do I design the backyard of this back-to-back lots? And that's the one situation we didn't have last semester. And that's the last discussion today. And I'm just going to tell you what the relationship is. And I just want you to do it. Okay, so I'm going to give you the design concept. You have to put in the points for me. All right, and there's a sketch. I posted a sketch. It looks like this. So I posted a sketch. It looks like this, rear yard grading sketch. So there's a PDF. I'll show you here. So if you go to the content of the course, it's right here. Winter 2021, a rear yard grading sketch. Okay, so this is the concept. So let me show you what it looks like. This is the PDF I posted. Let me shut some of this stuff down. And I'll show one I posted. Looks like this. Right, and highlights exactly those backyards. Now, in order to do this, you need all your front lot corners, all your street line elevations. Okay? And in particular, you need this one, which comes from street B corridor, right? This elevation is just the street line elevation that comes from the corridor. And you need this one. So you need both those elevations from the corridor. And they come from your profiles are done, your corridor is done, your corridor model is done, your corridor surface is done, and you get this elevation and this elevation from your corridor model. Okay, so you need that. So you have to have those 2 elevations. Once you have those 2 elevations, you're going to do this. Use your distance at your slope distance, right? This command here. You're going to use, go back to the drawing. You're going to use create points, create points. You're going to use this tool here. slope grade distance. And this is the pattern, right? So I'm giving you the concept. You have to tell me what the elevations are. Starting at this point here, you're going to go down 2% to here. Whatever that solution is, from there you go down 2% to here. Whatever that is, you go up. This is a high point now. Okay? So the arrows, the magenta arrows, are the direction of flow. They point downhill. So from here to here you go -2. From here to here you go -2. From here to here you go up at +2. And so on. Down 2%, down 2%, up 2%. Down 2%, down 2%, up 2%. Down 2%, down 2%, up 2%. You can kind of catch the pattern, right? You go down 2 lots, up 1, down 2 lots, up 1, down 2 lots, up 1. When you get to here, right, from here you go up at 2%, stop. Then from here you go up at 2%, stop. And then one time only you use the high-low command. There's a high point right here. Somewhere in the back of lot 35 and 38, there's a high point. So once you have this, and the design starts here, you go from here all the way to here, stop. Then you go from here all the way to here, stop. And once you have these two elevations, if you use the high-low command up at 2%, you'll end up with a high point somewhere between this line and this line along the back. Okay, that's the concept. So basically we're creating this sawtooth effect because the slope from this point to this point, and this is the only hint I'll give you, and it might not be exact, but it should be close. Inquiry list slope. If I go from this node to this node, the slope is less than 2%. So instead of going down at 0.8%, which is too flat for a grass swale, minimum slope on a swale has to be 2%. If you don't believe me, you go to the standards. Okay. I don't know if Professor Naruzzi discussed this with you, but if you go to the standards for Town and Milton, and you go to the grading standards, if you go to the grading standards, right? Grading, where's the grading? Where's the grading? Lot grading and drainage. Minimum slope and sodded areas, 2%. So all the swales have to be 2%. Minimum slope and sodded areas, side slopes 3 to 1, but the minimum slope. So to get water to flow on grass, it has to be at least 2%. Okay. Swales. This is what I'm designing in the backyard. Between 2 and 7%, I would have to go minimum 2%. So instead of going down at 0.8% approximately, right? Instead of going down at 0.8%, I'm going to play this trick. I'm going to use the sawtoothing, right? I'm going to go down 2% for 2 lots, and then up 1 lot at 2%. Then down 2 lots, 2%, then up 1 lot at 2%. And then down 2 lots, up 1 lot. Down 2 lots, up 1 lot. It's actually 1.5 lots, and then down 2%, right? So again, use the distance command, right? Down 2, up, piggyback all the way to here, stop, and stop there, and then come up from this side 2%, stop, and then use the high-low command between here and here, up at 2% from each side to get this high point. That's the concept. You have to tell me what those elevations are. Once you do that, you'll have a backyard elevation and a front yard elevation. You know what to do in between, right? Offset 8 meters from the front, 8 meters from the front, offset 12 meters for the house, and there's your zone, right? When you do your high-low, you have to be between these two, right? You could be at the front, you can be at the back, or anywhere in between. That's a solution for a split draining lot. And that's, again, typical of this entire subdivision, okay? These ones are townhouses. They have to be split draining, okay? Because the buildings are too long. They have to be split draining. You can't flow around, so they have to be split draining. The only exception, like I said, is somewhere in here you might have some back splits. In here you might have some back splits. All right, and that's the lot grading. Can't do your lot grading until you have all your front lot corners. Can't do your front lot corners until you have a corridor surface. Can't have a corridor surface until you have a corridor model. Can't do a corridor model until you have your profiles designed. The bottleneck is the profiles. Without the profiles, you cannot proceed. Okay, so that's the order. Do your profiles, do your corridor model, do your corridor surface, get your front lot corners. Then you can import the points, interpolate. You can add the points to the middle between here and here. You can't do that until you have your corridor elevations from the edge here and here. Once you have those two numbers, then you can do the grading based on this concept. Right? So there's the concept. This is a sketch of the discussion we had at your desk when I came over to tell you to do this work. Right? So now you have an idea of what it should be, make it so. Fill in all the details. You're doing the detailed design. I'm giving you the concept. Okay? Any questions? So I've taught everything you need to know to proceed with all the lot grading, which is the biggest amount of work to do for this course, right? If you remember from last semester, there's a lot of lot grading to do. Excuse the pun. Get started on the lot grading, and once you have the lot grading done, you can do the drainage areas, okay? Sanitary, you can kind of do before the lot grading, right? Maybe we'll talk about that next week first, because you don't need the lot grading for it, but you can't do the drainage areas for the subdivision until you know where all your lot grading points are. And you'll see why when we do the discussion. Any questions? So if you're still not sure about how to make any corrections to your first submission, again, it's the stuff highlighted in gray. If you're not sure how to fix that stuff, send me an email, request a meeting, and I'll help you, okay? If I'll send you a meeting request. So you ask for the meeting in an email, and I'll send you the meeting request. And then we can do a Microsoft Teams meeting. We can share a screen, we can talk, it'll be much faster, okay? If you, again, I've said it before, if you try and describe a problem with screen captures and text, it takes forever. Stephen, if you choose not to rotate everything and make it look good now, you're going to have to do it at the end. So at the end of the course, you have to hand in your grading plan. So the presentation, I'm not going to be too critical of it now, but if you do it now, then the last submission, the final submission at the end of the semester will be a lot faster. So if you have the time, I suggest you rotate all your points and make them look correct, right? Make sure you have the correct style, make sure you have the correct layering, everything's rotated, not through the line. Remember all the presentation stuff we looked at before, right? You can use, and remember, as a guide, right, what's the grading plan supposed to look like? There's more information here than you need, but if you go to the grading plan for the site, kind of gives you an idea of what the grading plan should look like, right? So look at any lot grading, and you'll see all the information, right? So you can see all the points are rotated. You don't have to do this, right? The slope, you don't have to see, it's 2%, 3%, 2%, 3.5%, 2%, 2.6, 2, 2.1. You can see the lot grading. You don't need this stuff. You don't need the slopes. You don't need the arrows. I just want the elevations at the corners, front and back, and then whatever you do in between. That's it. Okay? But if you rotate it and put it in a spot where it's legible, that's perfect. A requirement in Milton is that you put the existing elevation at every proposed corner. We're not going to do that. I'm not going to waste your time. Okay? I know you know how to do that, but I'm not going to ask you to do it. So I just want the proposed front, the proposed back, and then whatever you do in between. The correct size, the correct font, 2 decimal places, rotate it so it's parallel to the lot line, right? Make it look as good as possible. I'm not going to be too picky on the presentation, right? It's really the design I want to check this time around, but if you take the time to make it look good now, it's less work at the end, right? So I suggest you do it now. It's up to you. Does that answer your question, Stephen? Okay. There's lots of time, right? This is not due till after the break, right? So during the study week, you have lots of time. I know you're doing other courses, right? I know I'm not the only course you're taking, but there's a lot of time before the submission. So do the design, and then make it look good now, and then the submission at the end will be a lot faster, a lot less work to do. So that's my advice. Okay, it can be done for this submission, but I'm not going to be too critical about it. I will be marking presentation on your final submission. At the end, I want PDFs. They have to be presentation quality drawings. Right now, I just want to check your design, right? So it's going to be design, 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 and then presentation with a cost estimate. Any other questions? Remember, you can unmute yourself. You can ask a question orally. Okay, if there's no other questions, I'm going to end there. Okay, that's a good place to stop. Next week, we'll discuss the drainage areas for sand and storm. And that's pretty much this for this submission. The last thing you need to do is create a surface, right? Which is just as simple as this. Watch. You go to create surface, call it FG. This is the same thing you did in the CDA. Don't create a style. I just want you to create the surface, but I'll show you what it looks like. Right? You don't need a style for this. And then for that surface called FG, add the point group called FG. And that builds your surface. And you can start to see mine is already kind of coming together, right? My front lot corners, I'll have an elevation at the back and everything in between, right? Okay, so you have to build the FG surface because I'm going to be marking it. I'm going to look at it in 3D and see if everything makes sense. Okay. Then actually that's all you need to do. Right? You have to. We're going to create this. And then it's not even going to be finished until we go to the cost estimate. There's a couple of tweaks you have to make to it, which is not something we're going to discuss now. Okay, so just do the lot grading design, and then we'll talk about the overall. So that's all you have to do. Create the surface, add the point group called FG. And you can see, right, these points are on the surface because they're in the FG group. These points are not on the surface. And that's why you need to make duplicates of them and put them on make sure they have the description. So this point, elevation, is on the finished ground surface because of this point, not the gray one. It's the blue one. And that's why you need proposed at the back to match existing. So if you want this elevation on the surface, you put a proposed point there. Update your point groups, rebuild your surface, and now that point is on the surface. That's the reason why you need to propose to match existing if that's what your intent is. If the elevations are different, then you know you're proposing a wall, and there's none of that on this site. There's no walls. Okay, and then I can review the surface. Okay, I don't even need to see, just create it, right? And when you give me the file, it's going to be no display, and I'll turn it on and I'll look at it myself. Okay, that's it for today. I'll see you next Tuesday. The blue points are on the perimeter, the limit of the subdivision. Okay, so you have a layer for the front lot corner. You have a layer for matching the existing, whether it's exactly the same or interpolated, right? It's all the same layer. And then you have a layer for the rear lot corners here, right? Which can be the same layer as the blue ones, right? You can use the same blue back here, same layer, same color. And then you need one more layer for the proposed, whatever you do in between, right? So 1, 2, and a third layer for what you do in between, right? So there's a proposed front, a proposed rear, which is interpolated from existing, and then a proposed design. So 1, 2, and then one more layer for what happens in between. 3 different layers, all the same description. They all go into this group. Proposed front, proposed rear, proposed design in between, 3 different layers, all the same description. They're all going to look the same, but all going to be in the same group, but they'll be on different layers. The existing imported points go in their own group and in their own layer. That's just for reference. So among the gray points above, we need only select the ones between. Yes, yeah, that's a good point, Trong. So if you look here, right, I did every one. If you look at the diagram that I gave you, the handout, let me go back to that. That's a good point. If I go to, where is it? Yeah, if you look at the back here, you only need, see how we're skipping? We're not doing every single one at the front. We're skipping. we're doing the block lines and then the ones in between, every other one, right? So when we're doing townhouses, we don't do every single line. So wherever I have a proposed at the front, you need a proposed at the back. You need a proposed at the back. You don't need this one, the blue one here. You don't need something in the middle here. Does that answer your question, Tron? So we're doing proposed at the front, proposed at the back. If there's no proposed here, you don't need a proposed here. Yeah, that's right. Yeah, that's only true for the townhouses though. I'm skipping the ones on the townhouses. I'm doing every other one. Because they're so skinny, right, compared to these, I'm going to do every other one only. That's enough detail. Okay, but the individual lots have every corner done. Yeah, that's a good point. And I believe that's what they did here. If you look at the townhouses here, they did every other one. So if you look at Chuchmak here, oh no, they did every one. See, they did every one. I don't like that. That's too much information. So if I was designing this, I would show the design of this and this, because that's the block limits. But in the middle of the townhouse unit, I would skip this, this, and this. I would only show every other one. So please do what I suggested here. If there's a proposed at the front, you need a proposed at the back. If there's nothing here, you don't have to do that one. Yeah, that's a little less work too. This is my preferred way. It'll be close enough to what you have to do. Any other questions? Okay, that's it for today. I'm going to stop the recording.